Hi, this is Mr. Snyder with Truman Middle School, and today we are going to solve two-step inequalities. So our objective is to learn solve two-step equalities and be able to graph the solutions on a number line. So solving a multi-step inequality is really the same as solving a regular equation. You're going to use inverse operations to isolate the variable. Multiplying or dividing the inequality by a negative number, however, reverses the inequality symbol. So that's really the one thing we need to be careful of. So treat the symbol as an equal sign, but if both sides get divided by a negative, you have to switch the sign to the other direction. So be mindful of that as we move on. So just like the equation 4x plus 1 equals 13, we would treat this really the same way. We would start by doing inverse operations to isolate the variable. So we will subtract 1 from both sides. Once we subtract 1, we are left with 4x is greater than 12. So now in order to completely isolate the variable, we would divide by 4, and we would get a solution. X is greater than 3. To graph that, just simply draw out your number line. Since x is going to be greater than 3 but not equal to, that means that we would leave the hollow circle. So put the hollow circle down, and greater than 3 means all numbers to the right. So our arrow would go to the right. This is where we need to be careful. If both sides of an inequality are multiplied or divided by a negative number, the inequality symbol must be flipped around or reversed. So let's look at how that might work. So just like the equation minus 4x plus 2 is greater than or equal to 18, we do inverse operations. We start by getting rid of the 2. So subtract 2 from both sides. You're left with negative 4x is greater than or equal to 16. Here's where we are dividing both sides by a negative number. So if we divide by a negative number on both sides, then the sign flips around. So now it reads negative 4x is less than or equal to 16. But since we've canceled out our negative 4, that really means that x is greater than or equal to negative 4. So just be careful. You're still solving it just like an equation, but since we divided both sides by a negative number, we had to flip the sign around. And to graph that, put the number line down. Since x is less than or equal to negative 4, we put a solid circle on negative 4, and then we choose all numbers less than that, which means it would go to the left. For the next example, we deal with our lovely friends, the fractions. So remember, we have to clear out the fractions by multiplying by the LCD. And the LCD of 5, 4, and 10 would be 20. So let's multiply every single term by 20, and good things happen. Things cancel. So after we cancel out all of our denominators, we are left with 8x plus 15 is greater than or equal to 18. So now we would proceed as normal. We would subtract 15 from both sides. We're left with 8x on the left and 3 on the right. So 8x is greater than or equal to 3. So now we divide both sides by 8. And this time we're left with a fraction, which can be tricky when you're graphing it, but let's keep it simple. Let's make a number line that's broken into eighths, and that way we can graph this very easily. So I have my graph. I find 3/8, and since x can be equal to 3/8, we put a solid circle, and we want all x's greater than that, which means it will go to the right. So that's how we walk through these. Let's go ahead and do some together on paper. So let's start with our first one. First of all, let me choose a lovely color. So our first inequality is 7y minus 4 is greater than 24. So I'm going to start by simply adding 4 to both sides. And once we add 4 to both sides, we have 7y left over, greater than 24. So now we simply divide both sides by 7, and we get y equals 24 over 7. Not the prettiest number to work with, but not to worry. Since 24/7 is really the same as 3 3/7, I might start my number line at 3 and I'll take it up to 4, and then I can divide the middle part of it in sevenths. So here would be 3 and 1/7, 3 and 2/7, 3 and 3/7, 4/7, 5/7, 6/7, and then 4 would obviously represent 3 and 7/7, or just 4. But we want 3 and 3/7, because that's really my answer, and that would be right here. And since it's y's greater than that, I'm going to leave an open circle, and then I will graph everything to the right, since I want numbers that are greater than that. So even though this had an ugly fraction, it wasn't that horrible. The next one, we are going to start by subtracting 4 from both sides to clear out the 4 on the left, and we're left with negative 2x is greater than 24. Remember, since we are dividing both sides by a negative, we need to flip the sign in this example. So this would be x, flip the sign, now it's less than, and 24 divided by negative 2 is going to be a negative 12. So I'll make my number line. I'll put negative 12 here in the middle, and then I can do negative 11, negative 10, and on the other side we'll do negative 13, and we'll do negative 14. So since x is going to be less than, not equal to, I'm going to do an open circle, but we want the x's that are less than negative 12, so that means it's going to go to the left. If a fraction or inequality contains a fraction, we need to clear out the denominators. So the LCD of 8, 6, and 12 would be 24. So we're going to multiply every single term times 24. So let's go ahead and do that. So make sure you're distributing 24 to all 3 terms, and then we can go back and cancel as necessary. So I'll divide out an 8, I get 1 there. Divide out an 8, I get a 3 here. So this turns into negative 9x. Here I divide out a 6. I divide out a 6, I get a 4 there. Multiply 4 times 5, you get 20. So far I have negative 9x plus 20, and over here I forgot to multiply by 24, so I'm going to go ahead and do that now. Now I can divide out a 12, and I get 14 on that side. So I'm almost done with this. I need to just treat it the way that I've been treating it, treating equations before. So let's just write this off to the side. We have negative 9x plus 20 is less than or equal to 14. So now I want to subtract 20 from both sides, and I get a negative 6 on one side. I have negative 9x on the other, and my sign is less than or equal to. But since I'm dividing by a negative, I need to flip the sign here, and I will get x. My sign is now flipped, so it's greater than or equal to, and negative 6 over negative 9 is actually going to be positive 6/9, or you could simplify it to 2/3. So to graph it, I'll do 1/3, 2/3, and then over here 3/3. Sorry, this is getting so crowded, and this might be 0 right here. So x greater than or equal to 2/3 means I'm going to include 2/3 and everything greater. So sorry it got kind of crowded and messy there, but I think you get the point. And that's it for today. So good luck with the homework.